Okay, so we're just going to make a start at this time. I didn't really officially schedule that we'd be meeting today, since today is the last day of our course in terms of sending in the coursework, but I still wanted to offer the chance for anyone who might log in at our normal time for an optional live online session. So this week we have been looking at special senses, and we also have our final set of tests, so exam tree and practical tree to complete. I wanted to first of all start by kind of recognizing that we're at the end of the semester and the importance of getting all of the assignments that you want to count towards your final grade submitted by the end of the day today. As always, I do want to kind of outline what's the expectations in terms of the homework. I have especially a note on the discussion forums, and then we'll talk briefly about what to expect with exam tree and practical tree. We will spend a little bit of time also, I don't know if I'm going to flip around this order, but talking about the key takeaway messages from the chapter material, and then what's happening next after you've submitted all of the assignments by the end of the day today. So having said that, it has been quite a busy semester. I know we have covered a ton of material and we have done so in a short period of time. So for me, that speaks testament to your ability to manage your times, manage your workload, and be fiercely focused on where you want to be. Having said that as well, we do have to wrap up. All the good things come to the end, and we're going to be wrapping up this course. Today, Wednesday, the July 16th, is going to be the last day to submit any work that you want to count towards your final grade. So may it be homework assignments, may it be tests, may it be optional assignments, or anything else. All of that needs to have reached me by the end of the day today. 1 minute before midnight is when the assignments close. This is important because tomorrow I have to submit your grades to our registry. So the turnaround time is short. I've given all of the flexibility that I can give on the calendar for you to get those last assignments. So please, please, please make sure that anything you want to count towards your final grade, you get it submitted by the end of the day today, which is Wednesday, July 16th. So let's have a look. What are the assignments that we have for this week? Like I said, we're covering our final chapter, which is, I believe, chapter 16 on your materials. So I have a quiz about that, and that's completed on the Connect, which you are familiar with from our publisher's platform. And I also have a discussion that goes with that chapter. I do have a little bit of expectation in terms of the discussion, same as I had last week. And because I saw that we had a little bit of reading of a few different ways how the expectation was, I want to be super clear and super transparent of what that is for the discussion. So I'll talk about that next. In addition to that, we have for this week our exam tree and practical tree. And for those, I also have a discussion. For that discussion, I'm simply looking for one post, and one post is enough, and you can freely choose what the content of that post is. Typically, students tend to share maybe tips, hints to their peers, suggestions, or comment on their learning, how they found the test. So let's have a look of that chapter 16 discussion, that what's the expectation. For that, I'm looking for 2 posts in total if you're pursuing for those full marks. One of those should be at least one, a response to your peer. And one of your posts should also include a question that your peer can answer. So you'll see the illustration that I'm sharing on the screen is very much capturing the ethos of these discussion forums. We started early on of the semester, and I was very willing and happy to take the lead of kind of giving you prompts and giving you follow-up questions. And then we kept growing, that the expectation came not just 1 post, but 2 posts. Expectation came that you answer to the prompts that I shared. And then last week, you got to take the lead that it was actually fully student-driven forum. I did not present those potential questions, but students created questions for students to look into. That's a great way of learning. If you can think of what could come up in an exam, you're really digesting that material to the level that you should be. So we're going to follow that format on this final chapter discussion. So please consider doing that. In terms of the exams, both exam and practical will cover the same chapters, chapters 12, 14, 13, and 15. So the nervous system content, with the exception that I haven't put the special senses to these tests. In an exam, there's going to be 22 questions in total. And again, reviewing those chapter quizzes is probably the best possible way to practice for. You will have 60 minutes to answer these. So again, many of those questions are going to be very straightforward, quick to answer. Some of the questions will include multiple steps. I don't think you will have enough time to look up every single question, but if you have a question that you're particularly struggling with, you definitely have a chance to refer back to your notes on that. I would encourage you, though, to have your notes easily available. Be clear where in your notes you can find answers and so. It is 100 points that you can earn from the exam tree. It is completed in single settings. So once you first log in, that 60-minute timer will start running. It is not proctored, so you don't need to log in through any particular means. And it is an open book. But like I said, I think most students find that they either know the answer or they don't know the answer to the question. And like I said, you do have a chance to look up few details, but I would really encourage you to at least be prepared for the exam. So it's not the first time you start looking at notes or the first time you start looking at your text. Let's have a look at those couple of questions that I have there on the screen as an example. It's first one of those is a true-false statement stating that a nerve cell is known as a neuron. And we, of course, know that that's true. The second is also a true-false statement. It says that axons carry signals towards the body of a nerve cell. And we know that that's going to be false. Axons carried signals away from the body of the nerve cell towards the axon terminals. It was dendrites that carried messages towards the cell body. So you'll see that again, that gives you an idea. Those are questions that you really quickly are able to say that I got this, or this is something that I don't quite know. And if you don't quite know it, where could you find the answer? In terms of the practical, same chapters, you have 15 questions. It is going to be, I present you a picture having labeled a particular structure, and I ask you to choose what best describes that structure from a list of options. There's going to be 15 questions. Having completed practice anatomy assignments is going to be helpful for those. You have 30 minutes in total. It's worth of 50 points. So again, I think that most of you either know the answer or you don't know the answer. If you need to check one or two questions, you will have time, but you won't have time to check every single question. This is a single setting test, so once you start, that 30-minute timer will start running. And remember that it is non-proctored open book, so that's an option for you as well. So let's have a look of the material from this week, a couple of highlights, what we might want to know about the content. So we rely heavily on our senses. Different animals rely on different senses. For example, humans have a lot of visual information that we rely on how we interact and navigate the world. Snakes actually have, for example, a different kind of a vision. They look at especially thermal differences or temperature differences with their vision to, for example, detect the prey. Sheep, if you looked at the sheep brain dissection video that we had on our course, sheep rely heavily on smell, so they have larger adaptations, for example, in terms of the amount of brain area, in terms of, for example, the olfactory nerve. Our first cranial nerve is much more prominent in sheep than it is in humans, and so on. Special senses really refer to receptor organs that are large and complex structures, and we find these receptors in those localized clusters. And the sense that I wanted to start with, and I think a lot of my material focuses on, is sight. But just for the sake of completeness, I am going to mention a few others as well. And again, if we think of that comparative anatomy and physiology, we do see that humans rely greatly on vision. About 70% of all sensory receptors are located in the eyes. Each eye has over 1 million nerve fibers carrying information to the brain. And we will not cover all parts, but I do want to highlight some. And then we'll talk a little bit about the physiology as well. So one thing that I don't think often gets considered is that eye is one of the easiest ways for poisons and also pathogens to get into the body. So we need to have an alternative way to protect this route of entry. And this is, in fact, our tears play an important role in that. They help to clean the surface of the eye, protect it against pathogens, moisten so that it doesn't dry out, or, for example, we see dry eyes are a clinical issue, and also lubricate eyes so that they can function. Tears contain materials to protect and clean and so on, including antibodies, so part of our immune system responses, lysosomes, and which are enzymes that destroy bacteria, and so. So really important in multiple more settings than just vision. The importance of the eyes is probably well captured in the fact that we have 6 extrinsic eye muscles, which each of those attach to the outer surface of the eye, produce gross eye movements. And remember that 4 out of 12 cranial nerves were dedicated to the vision, and 3 of those are for the eye movements. So oftentimes when we're trying to establish whether the patient's central nervous system is potentially depressed, we might be testing for these extrinsic eye muscles because that tells us 3 out of 12 of the cranial nerves, how well they're working. So things like DUI testing on the field, on the roadside, might be trying to assess that as you're being asked to do very specific eye movements. And here on this slide, I do have structures of the eyeball and beyond. And even though we won't have a chance to review all of those, I did want to highlight in particular the retina from this diagram. This is where really the image that comes to your eye lands onto. And you will study a lot of this independently, but I want to focus on our discussion, probably one of the more tougher topics or topics that doesn't get as much attention, which is the physiology of the vision. So let's unbundle that a little bit. And in order for us to form a sharp, so in focus picture on the photoreceptors on the retina, light must be bent, as you see in this picture. And we have multiple structures that contribute to this. And it is noteworthy that eyes are optimally adapted to seeing things in a distance. And when I say in a distance, I'm referring to objects that are further than 20 feet away. And when we are looking at closer objects, so objects that are less than 20 feet away, the lens must change the shape. And this is what's known as accommodation. Other thing that I wanted to highlight is considering the image that lands onto the retina. And this image really highlights nicely that it is reversed from left to right, and it's also upside down, and it is also smaller than the actual object that we're looking. So a lot of changes in terms of how the image lands, and then our brains make sense of that. So that's going to be important for us. On the next slide, I wanted to briefly kind of highlight the image and how a retina really converts the light into nerve impulses. And let's study how they pass through series of structures, eventually resulting in interpretation of what we see. So we have optic nerve. That's basically an outgrowth of the brain that passes onwards from the eye. And then we have a part where partially these tracts cross over at the level of optic chiasm. And then these messages pass further along the optic tract to the thalamus, where we do a lot of processing and choosing what gets passed onwards and coordinating experiences. And finally, on the last two steps that I have, we're really getting to the occipital lobe of the brain, where we give meanings to what we're seeing. So remember, before that, these are just nerve impulses, but now we're starting to make sense of what those impulses actually mean to us. So quite a complex process, and process where, yes, definitely the sensory organ plays role, but also a bunch of other structures, and that brain's processing capacities become important, like we've spoken. I also wanted to mention a few concluding notes regarding the physiology of the vision. So each eye sees slightly a different view, and there is also overlap between both eyes. And this allows us to have depth vision. So brain interprets and combines these slightly different views, which allows us to form three-dimensional interpretation of the world. So that's going to be important for us as well. And now that we've looked at the vision in a nutshell version, I also wanted to talk a little bit about a few other senses. We're starting first by combining the hearing and equilibrium. So ear really houses and structures to do with ear, two senses. So the hearing and equilibrium, which really refers to the. And we will see different organs for these senses. And the receptor type that we're looking at here is mechanoreceptors. So they respond to mechanical stimulus, for example, converting sound waves and vibrations into nerve impulses. So lots to cover there. And let's start by kind of doing a division where we can see that ear can be divided into three different areas. So we have our outer external ear, we have our middle ear, and then we have our inner internal ear. And we will be able to read more details on each of those. But what I really want to do with our time here today is to focus on the most important parts of the middle ear. And out of those, I do want us to focus on the three bones of the inner ear. So these are incredibly small bones. We're going to see our hammer, anvil, and stirrup. And they do an important job of converting those sound waves into mechanical movement that then can be further processed at the other parts of the structures that we'll talk about. So like I said, their role is to convert sound waves, which are essentially more or less condensed air waves, and make them into movement to the fluids of the inner ear. And there can then they be converted into nerve impulses that pass to the brain. And I particularly like the next slide. I think it's kind of a useful one for us to unbundle a little bit. Here we see the pathway of vibrations from the sound waves. So remember, these sound waves are just within the ear, and how it gets converted then into nerve impulses and eventually becoming a perception in the brain as those nerve impulses are processed. So what we see is that we're seeing our eardrum that then moves the ossicles from the oval window, and the sound is amplified as a result of this process. And these pressure waves cause vibrations in the basilar membrane of the spiral organ of the corti, and hair cells of the tectorial membrane are then bent when the basilar membrane vibrates against it, and an action potential starts in the cochlear nerve. So that was our cranial nerve 8, and the impulse then travels to the temporal lobe. So a bunch of processes, I think rather fascinating and impressive process, how we can really make sense of just air that's condensed or less condensed and converted into neural impulses. I also wanted to talk about vestibular apparatus, which is a sensory system in the inner ear that helps you to maintain your balance and sense of spatial orientation. So vestibular apparatus includes 5 vestibular organs, including 3 semicircular channels that you can see there on the picture. So they detect your head's position and movement, which then helps you to coordinate your eye movements, your posture, your equilibrium, and sends nerve signals to the brain, which then helps you to make compensatory movements in response to that. And what we see here is really that hairs then respond to those changes. And let's look at that a little bit more. So here, what we can see is an example of the static equilibrium receptors as we change the angle of the head and how that then changes the perception. Well, moving along to the next set of senses, I want to talk about chemical senses. So taste and smell go together. Both are stimulated by chemicals in solution. And both of these senses also complement each other and respond to many of the same stimuli. So we will look at smell first. We can differentiate a wide range of chemicals. And then we will look at taste, which has 5 types of receptors that are particular. So I guess that I have next a couple of slides about the taste buds. Taste buds house the receptor organs for taste. They are located mainly on the tongue, but also on the soft palate, superior part of the pharynx and cheeks. And taste buds are frequently replaced by basal cells. So there's a quick turnaround in terms of those cell structures. And then if we think about the impulses from the taste buds, they are carried to the gustatory complex by several cranial nerves because taste buds are found in so many different areas. So we see our facial nerve, which was our cranial nerve 7, our glossopharyngeal, which was our cranial nerve 9, and our vagus nerve, which was our cranial nerve number 10. So finally, I wanted to also come back to this slide and mention the 5 basic taste sensations. So we have sweet receptors that respond to things like sugar, saccharins, and some amino acids. Sour receptors that respond to hydrogen ions and acids. Bitter receptors that respond to alkaloids. Salty receptors that respond to metal ions, and umami receptors that respond to amino acid glutamate or the beefy taste of the meat. So we see certain restaurants and certain dishes really capitalize on that umami. So I don't think that I said too much about the smell, but really the big thing to take away from there is that we're really now differentiating with a wide range of chemicals as it comes to that. So bunch of unpacking there to do. So what's going to happen? What's going to happen is that by the end of the day, all of the assignments should have been submitted, all of the work that counts towards your final grade. I will be finalizing those grades during tomorrow. You will receive an announcement where I tell you to check your grade book, check that everything looks correct in terms of your grades, and check that your final grade looks correct. You will have relatively short turnaround time to do that because I do need to submit your grades to the registry, and once that has been done, that is it for this course. I will be sending an individual message to each of my students, so you can keep an eye on that. I normally do it both through Canvas and email to your student email, where I kind of outline what are the next steps. I know I've been receiving quite a few questions asking about future courses that I might be teaching, and I have not been ignoring your messages. I just want to make sure that I communicate it in a consistent way that's same and fair to everyone. So I'll be sharing details about that as well. And I'll be also sharing maybe a request if you have had a good experience, how you can share about that with my supervisors. So that brings us to the very end of everything that I had planned for this session. I do want to say at this point, you will still receive the message from me, but also on this kind of a almost live setting through a form of a recording, that it has been my pleasure working with you this semester. I know it has been a lot. I know it has been intense, and you have risen to the occasion and done an outstanding job. The discussions that we have been having on the discussion forums have been excellent. This group is filled with so much knowledge, so much expertise, and so much wonderful thinking that it has been a pleasure. It has been my honor to get to work with you. And I am here to help you as you continue moving ahead on your academic journey. You've been my students and you will always be my students. So if you ever need any help, if there's anything I can do to assist you, I am here for it. That is one of my favorite parts of my job, to get to assist my students. So on that note, I think we've come to the end of this recording as well. As always, I appreciate you. I'm grateful for getting had a chance to work with you, and I look forward to seeing very last few messages that I think that we're still waiting to come through on our discussion. Please remember, all work is due at the end of the day. So don't leave the exam to the very last moment, just in case there's technical issues. And let's finish strong and get you those great final grades that you deserve. Until I see you next time, thank you and bye.